In the first part of this MPI tutorial, we're going to get you used to the way that MPI thinks about parallelism. Maybe you've studied parallel algorithms in a math-oriented class about computational complexity and such. Maybe you've seen PRAM, but MPI looks nothing like that. So we're going to get you into a new way of thinking about parallelism and teach you a couple of commands in the process of doing so. Okay, to understand how MPI works, you need to think back a good 20 years about what computers looked like when MPI was first designed in the mid-1990s. In those days, you bought a beige box which contained one processor, and you could run a scientific code on that. And so you had a process that would be taking up all of your CPU. So one box, one processor, one process. If two boxes needed to communicate, they could only do so through a network. Well, these days, computers are a bit more complicated. So now a box may contain two processor chips, and each chip contains a number of cores, and each of these cores can run a process. So one box, two chips, 12, maybe 20 processes. Okay, so we call the chips a socket, and MPI now no longer thinks in terms of the boxes. It doesn't think in terms of the chips or the sockets, but it thinks in terms of processes, and a process sort of corresponds to a core. And now MPI processes behave as if they're still in this world where two processes could only talk through the network. Never mind that in your modern processor, your processes are a fraction of an inch removed from each other and they share memory. To the programmer, processes look like they can still only talk through a network cable. So basically we pretend, to first order of approximation, that shared memory does not exist. Now you could, of course, run one process on your box, and that spawns threads on all of your cores. That's called hybrid programming. But that's more complicated, and we will not talk about that at first. So now we have a bit of ambiguous terminology. What is a processor? Is that a chip, or is that an independent instruction processing unit? So instead, we don't use the word process, and we talk about a socket if we really want to talk about the chip. And a core is one instruction stream processing unit. But mostly, we will use the terminology process. So a process is one running MPI Unix process. Now, SPMD is the basic model for MPI, which stands for Single Program Multiple Data, which means that you write one source code and then you create multiple processes that each is an instance of this same source code being executed. So this can be called symmetric because there is no master process. All processes are equal. They start and end at more or less the same time, and none of them have any privileges in being in charge of your computation. They collaborate symmetrically. And the second point is that communication calls also don't see any structure that there is to the cluster. They don't really see that one process is close to another or more far removed from another. So to send or receive data is the same no matter where your neighboring process is located.